Next concept I would like to discuss is debug symbols. To understand what is symbols, we need to understand what is a program again. Like I mentioned before, a program is nothing but instructions to CPU. CPU instructions are binary, ones and zeros, which we don't really understand or difficult to understand. Group of instructions are functions. Functions are pretty easy to see and understand when it comes to debugging. Another thing a program deals with is different memory or memory locations. When the source code is present, it has names as well, which is nothing but the variable names. So when the code is converted to binary using a compiler, linker, or any other tools, all the symbols are lost. All the names are lost. And it is completely converted into binary ones and zeros. That is what is getting lost. Now, when we look at a dump or a live debugging scenario, we don't have any information about the binary files. That is the information which is present in symbols. Now let's have a look at a demo and let's understand what a symbol is in a program scenario. So I'm going to take the same example which we have seen yesterday. This is a simple application. It's a hello world application which just prints hello world. I'm going to start it from the debugger like we discussed yesterday. I've started a copy of the WinDebug. I'm going to open the executable. So I'm going to open the executable. Right now itself, we can see a lot of strings. For example, this is a string. This is not a pure binary. This number is a binary. Anything which is hex is a binary. But we are seeing a lot of names here, And if I type the call stack, you will see another name here. And if I go press G, it will break into the debugger and we even got source code. Now, K, if I press the call stack command, which is K, again, we get a lot of names. These names are not part of the binary. These names are not present in this file. Let me show you. This is a file in which we have the code. Okay, so let's open that file in Notepad. This is a file which has a code. It has all the names, char P, all the names are there. Main, argc, argp, all the names are there. Once this file is compiled, it is going to be ones and zeros. And this file which is present here, so this is the final output, the binary file. This file doesn't have any of those names. It's just ones and zeros, no names at all. If we open up this particular binary, you will not see any of the names we are seeing right here. Now the question is, where is this names coming from, It has more information like where is the source code, all the location of the source code, all this information is coming. None of that information is coming from this file, which is the program itself. That is where the symbol coming into the picture. Symbol, which is this in this case, hello world.pdb or program database, is where all the mapping of the binary to names. So it's more like a DNS, if you will. It converts binary addresses to names. Now let's see a whiteboard to better understand this. We have the program here. This is the hello world.cpp. This is a text file at the end of the day. This file has all the information we need. The file is getting compiled. So this is the compiler. Once it is compiled, what will happen? The output of the compiler, we have seen this diagram before, has only binary. This is a binary file which is getting generated. Compiler doesn't generate the exe file. In fact, it is the linker which generates the exe file. Compiler generates an obj file, but it doesn't matter. So I'm going to put an exe here, hello world.exe. Linker is coming into the picture just to be complete. The hello world.exe is completely binary. Now, along with generating this binary, the linker will also create hello world.pdb. This pdb file, this is a file which has all the names from this source code. It comes all the way from here and it will end up here. All the function names and variable names, details about optimizations, stack frame sizes, a lot more information. It's completely for debugging purposes. because no one can make any sense out of this exe because it's only ones and zeros. That is the concept of symbols. You can think of symbols like a table. One side of the table is the binary numbers, the addresses. This is ones and zeros. Of course, when we represent, it will be in hex, 0x. And the other side is names, main, then different functions, variable names, argv, argc, etc., etc. So there are a lot of commands which we're going to see, like x command, ln, a lot of commands in debugger which you can, if you have this, you can get this. If you have this, you can get this, so on and so forth. We'll see that. Another thing worth mentioning here is that there is a pairing between, there is an entanglement. They are generated at the same time. They have a timestamp matching between these two. For example, if I build this again, this exe again, this file also changes. And we need the exact copy of exact pair of this PDB file for debugging. Anything else won't work, even if it is from the same source code, because the version of the linker, a lot of things can change the layout of this binary when it builds the binary. So even if the source code is same, it doesn't matter. You need to have the exact same binary and the PDB which you got when you built that particular binary. That is another relation between the binary and the PDB. Most of the cases, linker will always, unless you configure the linker or the compiler in this case, otherwise it will always generate the PDB files in the exact same folder as the binary by default. We have seen the concept of symbols. We have seen this whiteboard.